In this video we're going to look at fuels, and we're specifically going to look at the group of alkanes. So we're going to discuss sources of hydrocarbons, and we're going to explore names, formulae and isomers of alkanes. So first of all, looking at fuels, you're dealing with a small branch of organic chemistry, and it involves the study of compounds that contain carbon. And carbon has 4 bonds always. So first of all, definition. What are hydrocarbons? Because hydrocarbons are the central point of fuels. So hydrocarbons contain hydrogen and carbon atoms. So their molecules are compounds that contain hydrogen and carbon atoms. And then fossil fuels. Fossil fuels are fuels that were formed from remains of plants and animals that lived millions of years ago. And examples of fossil fuels include crude oil, methane, natural gas and coal. And methane is produced naturally in the likes of slurry pits, coal mines and from dumps where your rubbish goes. And this can have a hazardous effect on the earth and is a greenhouse effect contributor. So in this video we're going to look specifically at the family of hydrocarbons called alkanes. Now there's 3 families of hydrocarbons, or 3 classes, and that is alkanes, alkenes and alkynes. And the difference in all of these is based on the carbon-carbon bond type that is present in the molecule. So alkanes, alkenes and alkynes are part of the homologous series, and the homologous series is a group of compounds where all members have a general formula and have the same functional group. Each member has a similar method of preparation, so that means they're produced in a similar manner, and each member differs from the previous by a CH2 unit. So as we go through our alkanes, alkenes and alkynes, I'll come back to these properties that allow them to be part of the homologous series. So let's begin with alkanes. Alkanes can be often called paraffins, and they are the hydrocarbons where all atoms are linked by one bond, or a single bond as it is more commonly referred to as. So the functional group is C single bond C. And alkanes are saturated molecules. And our definition for saturated molecules are molecules that have single bonds only. And how I remember saturated molecule definition is S for saturated and S for single. So if we look at the names, formulas and structures of different alkanes, the first alkane is called methane, and it has a formula of CH4, and this is the structure here. So we said that carbon will always have 4 bonds, so that's why there's 4 hydrogens, and this is the layout of the hydrogens in the structure. The second name is ethane, and it has a formula of C2H6, so 2 carbons, and it has the chemical structure as follows. And you can follow the rest of these down in the rest of the video. You've got propane, butane, pentane, hexane, heptane, octane, nonane and decane. And these, the first few letters, or the first part of each name, is the same for all of the hydrocarbons. So all of your hydrocarbons will have the start that I am highlighting here in yellow. So meth, eth, prop, but, pent, hex, hept, oct, non and dec. The only thing that changes is the ending based on whether it's an alkane, alkene or alkyne. But here we're looking at alkanes. So alkanes always have the ending ANE, 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 ANE. So you add ANE onto the end of your stems, which are highlighted in yellow. As you'll see on the previous slide that we've done, the structural formulae are planar and do not show the shape of the alkanes. So when I say planar, they're drawn like this with just single line bonds coming out of them. But that's not the true shape of an alkane. An alkane that is carbon has a tetrahedral shape like this. So the wedge and the dash just shows that one of the hydrogens is pointing towards us and one is pointing away. And these two hydrogens are in the plane of the page. Now, this is not extremely important at Leaving Cert, but I think it's important for your understanding. And also, it has been touched upon in the bonding videos that are available. Now, if you remember, as part of the homologous series, we said that all of the compounds must have a general formula. So the general formula for alkanes is CnH2n plus 2, where n is the number of carbons. Now, if we just do an example of this here, and we say that n is equal to 3, so if n is equal to 3, we're dealing with propane. So propane, it should be C3H2 times 3 plus 2. So it should be C3H8. So if we draw that out, C, 1, 2, 3, 4, 5, 6, 7, 8. We can see here that we are correct, C3H8. Now, another thing that I want to show you just up here in the top right hand corner, we know that propane now is C3H8, so that's propane. Butane then would be C4H10 if you followed the formula. If we went with pentane then, it would be C5H12. And if you look at, to go from propane to butane, you've added a CH2. To go from butane to pentane, you've added a CH2. So this indicates further that the alkanes are members of the homologous series because they have a general formula, but each molecule differs by a CH2 unit as explained up here. Now, as part of the alkanes, you may be given a structure and asked to name it. And if you are given that, these are the following steps that you need to take. You should identify the longest continuous carbon chain. You should identify any substituents attached to the chain. So when you identify your longest chain, there may be things coming off it that you might need to be able to name. Number the carbon chain starting from the end that gives the substituents the lowest possible numbers. Indicate the position of the substituents, that's using the numbers that you'll have numbered in step 3. And then assemble the name listing everything alphabetically. So the groups alphabetically, that must happen. So let's look at an example. So let's look at this molecule. So the first thing we need to do is we need to identify the longest carbon chain that is present. So here we can see we have a carbon chain of 1, 2, 3, 4. Or we have a carbon chain of 1, 2, 3, 4, 5. So clearly my longest carbon chain has 5 carbons in it. So step 1, there's 5 carbons. So that means I'm going to be dealing with pent. Now, the next thing I would do is look and I'll see, okay, there's no double bonds, there's no triple bonds, it's all single bonds. So it's definitely going to be pentane. Step 2 then is to identify any substituents that you have. And I can see that I have 2 substituents here. I have a chlorine and I have a methyl. So chlorine will always be called chloro, and it will be the same if you bromine, it would be bromo. And then you have methyl, a methyl group as well. So step 3 is to number your carbon chain, and you number it so that your substituents have the smallest possible numbers. So there's 2 possible ways that it can be numbered. It can be numbered from left to right, or right to left. So let's try both ways. So you can do 1, 2, 3, 4, 5, or you can do 1, 2, 3, 4, 5. Now, how do you pick which way is correct? You pick the way that gives the substituents the smallest number. So here I can see that the chloro has a 2 or a 4, and the methyl has a 3 and a 3. So for methyl it will all be 3 either way, but for chloro we want it to be 2, because you want the smallest substituent. So it'll be 2 chloro, 3 methyl. So that means you are numbering from left to right. So I'm just going to remove these ones here. So we've now numbered it correctly. Step 4 is to indicate the position of your substituents. So I've done that. It's 2 chloro and then it is 3 methyl. And the last step then is to assemble your name alphabetically. So pentane will always go on the end. So you need to decide whether it's 2 chloro or it's the 3 methyl that goes first. And it is going to be the chloro that goes first because it is C. The C comes before M in the alphabet. So it's 2 chloro, 3 methyl pentane. That is the name of that structure. So let's try another example. So again, step 1, identify your longest carbon chain. So if we look here, we can see 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. So as we can see in both of them, the longest carbon chain is 7, so that's okay. So 7 carbons, that means it's going to be hept, and we can see that there is no double or triple bonds, so it's heptane. Step 2, identify your substituents. So we've got a methyl, we've got a chloro, and we have a bromo. Next thing to do is to number your carbon chain. So this can be done 2 ways. So we can number it 1, 2, 3, 4, 5, 6, 7, or we can number it 1, 2, 3, 4, 5, 6, 7. So you have to look at both ways. So if we're working left to right, it would be 2, 4, and 5. But if we're working right to left, it will be 3, 4, and 6. So it is the top line that we'll go with. We'll number it left to right. So that must mean identify the location of our substituents. So it will be 2 methyl, then there'll be 4 chloro, and 5 bromo. And the last step then is to assemble the name alphabetically. So first will be 5 bromo, because B, followed by 4 chloro, followed by 2 methyl, and then you put your group in the end, which is heptane. So another way that this could be brought up is you could be asked to draw the structural formula and when you're given the name. So here you can see you've got 3-ethyl 2,5-dibromohexane. So the first thing I would do is I would identify my longest carbon chain. So my longest carbon chain is hexane, so that means there's going to be 6 carbons in my longest chain. 4, 5, 6. Then identify any substituents. So it says dibromo 2,5, so there's going to be 2 bromines and an ethyl. It's going to be an ethyl, which is C2H5. So now look at the numbers. It says 3-ethyl 2,5-dibromo. So I'm going to number my carbon chain here. 1, 2, 3, 4, 5, 6. So the bromo goes on 2 and it goes on 5. Now it doesn't matter whether you put it on the top or the bottom. It doesn't matter if it goes up here or down here, that doesn't matter. And it's 3-ethyl, so it's 3-ethyl C2H5, and then all of the other bonds just have hydrogens attached to them, like this. And once you fill in all of your hydrogens, you've now drawn the structural formula of the name. And I'm just going to rub out the numbering system that I had here, because you don't need it anymore. So that is the structure now of 3-ethyl 2,5-dibromohexane. And just to point out that the di here, dibromo, means that there's 2 bromos. So isomers are next, and our definition for isomers: structural isomers are compounds with the same molecular formula, but a different structural formula. So we're going to look at the isomers of butane. So the first thing when looking at isomers, something is always an isomer of itself. So that means for butane, butane will be an isomer of itself. So butane is our first isomer. Now isomers have the same chemical formula but different structural formula. So for isomers, what I do always say is the easiest thing to do is to swap 2 groups. So always swap the end carbon with a carbon that's in the middle of your chain. If you swap those, what you'll end up with is 2-methyl propane. Showing, if I highlight these for you, this methyl group is now up here, and the hydrogen is now down here, and they've been swapped. So that's now 2-methyl propane, because prop, your longest carbon chain, is 3, and the methyl is on carbon 2. So they're the 2 isomers of butane. So let's briefly look at the isomers of pentane. So it's a similar thing again with pentane. As I said, isomers, something is always an isomer of itself. So pentane will be your first isomer. So what I would say is, if I was to draw pentane out for you in a large format, you would get the following. So here we can now do similar to last time. If we take this methyl group and swap it with one of the hydrogens that's here, what you'll end up with is you'll end up with methyl butane. So we can get one more isomer out of this, again, by swapping the end group here with a hydrogen attached to a carbon in the middle. So you would not choose this carbon here, or you wouldn't choose this carbon here, because that wouldn't change the structure. You would choose this carbon here. And what that would give you then is it would give you 2,2-dimethyl propane, which has an expanded format as follows, and they are your isomers of pentane. So some physical properties of alkanes: they are nonpolar, so they're insoluble in water, but they are soluble in organic solvents as a result. They're quite unreactive, they have no taste or smell, and they are colourless gases from C1 up to C4. They are liquids from C5 to C15, and they are gases then from C16 upwards. The last thing to look at then is cyclohexane. So cyclohexane, as it's in the name, it has a cyclic structure, or it's in a cycle, and it is a formula C6H12 with a structure of a hexagon. And out of each carbon on the hexagon, there's only 2 hydrogens, because the other 2 bonds are accounted for attaching to the carbons adjacent to it. So that's it for this video. Have a read over the learning intentions to check you understand everything we've gone through.